Good morning, all the students. Now, the next topic of subject engineering graphics and modeling through AutoCAD is section of solid and development of surface. Invisible feature of an object are shown by dotted line in their projected views, but when such features are too many, these lines make the views more complicated and difficult to interrupt. In such cases, cus- it is customary to imagine the object as being cut through or sectioned by plane. An object is cut by some imaginary cutting plane to understand the internal detail of the object. The imaginary plane is called a section plane or cutting plane. The surface produced by cutting the object is section plane or called section. It is indicated with the thin section line uniformly spaced, that is not more than 2 to 3 mm at the angle of 45 degree. The projection of the action along with the remaining portion of the object is called sectional view. The action of cutting is called sectioning of a solid. The plane of cutting is called section plane. Two cutting actions mean section plane are recommended. Section plane perpendicular to VP and inclined to HP. Inclined to HP. Note this section plane appear a straight line. As a straight line. And second one is section plane perpendicular to HP and inclined to VP. In this, the section plane appear as a straight line in top view. Remember, after launching a section plane either in front view or top view, the part toward observer is assumed to be removed. Second one is, as far as possible, the smaller part is assumed to be removed. Like this. This is the first part in which this is a section plane inclined to the VP, and this is the second part inclined to the HP. Next, first the section plane is inclined with the axis at any angle to the HP, and assume lower part removed. This is the section plane inclined section plane or section line or imaginary line inclined with VP. The projection of the section on a plane parallel to the section plane will show the true shape of the section. When it is inclined, then there is a apparent shape of the section. Now we can find out the different types of problem in section of solid. That is section of prism, section of pyramid, section of cylinder, section of cone, and section of sphere. Now the conditions are section plane parallel to the VP. Here in this section of solid, the object cannot move on different position. Here the movement is of only, that is the section line or cutting line or imaginary plane. Only the movement of this. So we can rotate this section plane with different conditions. So the first condition is section plane parallel to the VP, section plane parallel to the HP, section plane perpendicular to the HP and inclined to the VP, section plane perpendicular to the VP and inclined to the HP. These are the conditions in which the section line or imaginary line can move for cutting the object. This is the section plane through apex. Then the sectioning of this surface is like a triangle. This is the section plane through two generators with including axis. Then we can find out this ellipse. Now the section plane parallel to the one of the generator, then it is a parabola. If the section plane is parallel to the axis, then this is hyperbola. If the cylinder cut through the all the generators, then we can find the shape that is ellipse. When square pyramid through all slant edges, then we can find out this trapezium. Now the next one is development of the surfaces. Development of the surface. Lateral surface of different solid. This is the cylinder with the height h and diameter d. With the height h and diameter d. We can open it with the help of 2 pi r. This is the prism. This is the pentagonal prism. Cone is open like this. Base parallel, radius, slant edge. This is a pyramid. Number of triangles. Tetrahedron. 4 equilateral triangle. Cube. 6 square faces. Development of the frustum of the cone. Imagine that a solid is enclosed in a wrapper of thin material such as a paper. If the covering is open out and laid on a flat plane, the flattened out paper is the development of the solid. Thus, when surface of solid are laid out on a plane, the figure obtained is called the development. Hence, it is very important to note that every line on the development must be the true length of the corresponding edge of the surface. Corresponding edge of the surface. Only the surface of polyhedra, such as prism, pyramid, and single curved surface as a cone and cylinder, can be accurately developed. What are the which object are accurately developed? First one is the prism, pyramid, cone, and cylinder can be accurately developed. And some of the double curve surface or triple curve surface cannot be accurately developed, like ellipse, sphere, paraboloid, hyperboloid, and helical. These are cannot be accurately developed. So the different method of the development in which the first two is most important, that is parallel line method and radial line method. And we have also two type of method. Next one is triangulation method and approximate. So in the development, so there are the four different methods of development of surface. First two is important because they developed the subject accurately, and the next two, that is triangulation and approximate, they are the double or triple curve surface that in which the object cannot be accurately developed. So this is the development of frustum of a cone in which theta is equal to r by L into 360 degree. So r is the base circle radius of the cone, L is the slant height of the cone, L1 is the slant height of curved part. Same process in the development of frustum of square pyramid, like this. In cone, we draw the curve directly from one point to the last point, but in the development of a square pyramid, it will move to from first to second, second to third, third to fourth, and then fifth, like this. This is the top side and this is the bottom side. A pentagonal prism 30 mm base side and 50 mm axis is standing on the HP on its base, whose one side is perpendicular to the VP. It's cut by a section plane 45-degree inclined to HP through midpoint of the axis. Draw front views, sectional top view, sectional side view. Also draw true shape of the section and development of surface of remaining solid. This is called a pentagonal prism, and this is the top view of the object, and above XY line this is the front view of the object, and we cut a section line that is 45-degree inclined with the HP like this A, B, E and C, D dash. Now this is the true shape of the section and development surface of the solid. So this is the true shape inside of the line, and this is and below XY line this is the apparent shape. And now we draw a new reference line parallel to the section plane as like XY. This is X1 and Y1. This is like a X1 and Y1. And when we move to the X1, Y1, it's mean we will move toward the XY. Now measure a distance from XY to the A, then E, then B, then D and C, and put like this and join the line. Then this is a pentagon. This pentagon is a accurate yet true shape. True shape. This is how we can solve the section of solid and development of this surface of remaining solid. Like this. This prism developed with the help of parallel line method. So we draw a parallel line and develop a development of the this cutting surface. Is this like this? A, B, C, D, E, A. This is the development of this object. Now the second question is a cone 50 mm base diameter and 70 mm axis is standing on its base on the HB. It's cut by a section plane 45-degree inclined to a V through base and end of the end generated draw projection sectional view true shape of the section and development of the remaining cell. So this is a cone with the base circle diameter is 50 mm and the height of the axis is 70 mm. This is the top view and this is the front view of the object. Above XY line, this is the front view and below XY line, this is the top view of the object. It is cut by a section plane inclined at 45-degree with the HP. This is the line. Now this is the side view of the object. This is the top view of the object and draw a line parallel to the section plane that is X1, Y1 and we draw a line like this. This is the true shape of the object. So we draw like this and this is the development of the cone. First we have to find the theta, then draw a line with the help of capital R, and this capital R or capital R draw the length and draw a curve. Now A, B, C, D, E, F counting. This is the curve of the development of the surface. This is the true shape of the section. This is the true shape of the section. This is the sectional side view. This is the sectional top view. And this is the development of this surface. A cone 40 mm diameter and 50 mm is resting on one of generator on the HP lying on HP which is parallel to the VP. Draw its projection. It is cut by a horizontal section plane through its base center. Draw sectional top view, development of the surface of the remaining part of the cone. Like this, we can draw This is the development of the surface. This is the sectional top view. This is the horizontal section plane, and this is the development of the this question. Thank you very much.